please take out this handout to follow along with the lesson. We're talking about exponent rules, different rules that we use to work with exponents. Before I get into it though, let's talk about some terminology. Here I have a familiar scene, 2 with an exponent of 3. So we know that this 3 is called an exponent. What's the 2 part called? Well, this is called the base. And this entire thing, the base with its exponent, is called a power. So a lot of times people get the words power and exponent mixed up. The power is the entire thing. The exponent is just the small number written above. And now let's just review how to work with powers. How do you evaluate powers? Well, it's important to remember what the exponent tells you. It tells you how many times the base is multiplied by itself. So I can take this power, for example, and I can write it in expanded form. Now what I mean is, I'm just basically writing out what this power says in multiplication. So 6 to the exponent 2 is the same as 6 times 6, because the exponent tells me how many times I'm multiplying my base by itself. So my answer is 36. Now be careful, if you have brackets with negative numbers as the base, you have to be careful with what that is. So we have an exponent of 2. That means we're multiplying the base by itself. In this case, the base is negative 6. So in expanded form, that's negative 6 times negative 6. And our answer is still 36. It's positive, because a negative times a negative is a positive. Here we have a negative base again, but this time the exponent is 3. So in expanded form, that tells us this base, minus 4, is multiplied by itself 3 times. So it's minus 4 times minus 4 times minus 4. Now minus 4 times minus 4 is positive 16, and that is now multiplied by negative 4 again, which brings us back to negative. So our answer is actually negative 64. Here we have a power, and it looks like a negative base, but watch out, there's no brackets. So the base is actually just 4. The negative sign is out front, so this entire thing is negative. The base is actually just 4. So we would write this as negative, and then the base is multiplied by itself 3 times, 4 times 4 times 4. So we still get an answer of negative 64. And a lot of people get confused when we throw fractions at them, but the principle is the same. Here we have a base of 2/3. The exponent is 2. So in expanded form, this is just 2/3 times 2/3. Well, if you know how to multiply fractions, it's the numerator times the numerator. So 2 times 2, that's 4. And the denominator times the denominator, 3 times 3. Well, that's 9. So our answer is 4/9. Now, using what I just talked about, try to evaluate each of these powers. I want you to answer in whole numbers or fractions. Don't just plug them into your calculator and get decimals, especially when we start dealing with fractions. I want you to practice what we did up here. So pause the video, try to get the answers for all of these expressions, and then check back in to see how you did. Take a look at these answers, check with yours. Make sure you didn't make any errors. If you did, let me know so I can help you figure out what the issue was. Pay attention to your signs, positive or negative. A lot of people, for this one as an example, will say it's a negative answer, but it's not. So watch out. Make sure your fractions are okay. If this is all good, then you can move on. If you had errors, please pause the video and let me know so that I can help you before you move on. So we know how to evaluate single powers, but what happens when you start adding more operations like multiplying and dividing to your powers? This is what we're going to look at now. So first we're going to look at multiplying powers with the same base. So here's an example. 5 to the exponent 2 times 5 to the exponent 4. We're multiplying these two powers, and they both have the same base of 5. Now I'm going to walk you through a couple of these just to show you a pattern, and then once you know the pattern, you can use a shortcut. So 5 to the exponent 2 times 5 to the exponent 4. I can write that in expanded form. 5 to the exponent 2 is just 5 times 5. 5 to the exponent 4 is 5 times 5 times 5 times 5. And I'm multiplying all those together. So when I look at it all at once, how many times am I multiplying 5 by itself? Well, 6 times. So I can rewrite that as a single power, 5 to the exponent 6. Now let's look at the next one, 3 to the exponent 5 times 3 to the exponent 2. 3 to the exponent 5 is just 3 times 3 times 3 times 3 times 3. Then I'm multiplying that again by 3 times 3. So that's a total of 7 times that I'm multiplying 3 by itself. So I can rewrite that as a single power, 3 to the exponent 7. Now, are we starting to see the relationship between the exponent in the single power and the exponents in our product? Here, 2 and 4. Here we have 6. What's the relationship? Here we have 5 and 2. Here we have 7. What's the relationship? Hopefully you can see 2 plus 4 is 6. 5 plus 2 is 7. If you add the exponents, it simplifies to give you the single power. So let's try this one without writing expanded form, because that's tedious. We have the same base, so over here we'll have the same base, minus 2. What's our exponent on the single power? Well, these exponents are 5 and 2. Add those together, it's 7. So our single power is minus 2 to the exponent 7. Try this next one on your own. Minus 3 to the exponent 4 times minus 3 to the exponent 3. Use our shortcut to write the single power. Pause the video and try it. You should get minus 3 as the base with an exponent of 7 because 4 plus 3 is 7. And this last one, some people get mixed up because of the fraction. And also, they don't notice that there is actually an exponent on this power. If you don't see an exponent, what does that mean the exponent is? Well, this is just being left by itself. So if you're multiplying something by itself only one time, it stays the same. So the exponent is actually a 1. If you don't see an exponent, that just means it's a 1. So don't forget about it. Now try this on your own. The base is 1 over 2, so we still have a base of 1 over 2. 3 plus 1 is 4, so our exponent is 4. So let's write a rule for multiplying two powers with the same base. As you can see, we just add the exponents together to get our new exponent in the single power. Now let's look at division. So here I have two powers being divided, but the two powers have the same base. We're going to go through the same idea as we did before. I'm going to write this in expanded form. So this division is 5 to the exponent 6 divided by 5 to the exponent 2. In expanded form, that looks like this. And I can see that there's a 5 and a 5 on the top and the bottom, and those cancel each other out because multiplying by 5 and dividing by 5 are opposites. So that cancels out 2 times, and I'm left with these 4 5s being multiplied together. So if I simplify this to a single power, I'm left with 5 to the exponent 4. Here we have 3 to the exponent 5 divided by 3 to the exponent 3, an expanded form that looks like this, and I can start canceling out some 3's. I'm left with 2 3's being multiplied together. So as a single power, this is 3 to the exponent 2. So what's the pattern? What's the relationship between these exponents and this exponent? Well, if before when we were multiplying powers, we added the exponents, what do we do with these exponents when we're dividing powers? Hopefully you can see 6 minus 2 is 4. 5 minus 3 is 2. Let's try that with the other ones. So here we have a base of minus 7. What's the single power? Be minus 7 as the base still. 3 minus 2 is 1. So it's minus 7 to the exponent 1. We could just leave this as minus 7, and that would be the same thing. Here we have 4 to the exponent 7 divided by 4 to the exponent 4. So our base is 4. What's our new exponent? 7 minus 4 is 3. So our answer is 4 to the exponent 3. Same idea over here. The base is a fraction, it's 2/3, but the base stays the same. 4 minus 3 is 1, so our answer is 2/3 with an exponent of 1, or we can just leave it as 2/3. So let's write a rule for dividing two powers with the same base. We subtract the exponents to get the new exponent on the single power. And lastly, we're going to look at a power of a power. So for example, here's a power. Now this power is the base of another power. So that's where the term power of a power comes from. You have a base with an exponent, and that whole thing has another exponent on it. So what is this in expanded form? Well, this exponent of 2 means that whatever's in brackets is multiplied by itself 2 times. So that's 5 to the exponent 3 times 5 to the exponent 3. Now 5 to the exponent 3 just means 5 times 5 times 5. So I can keep expanding this, and it ends up being 5 times 5 times 5 times 5 times 5 times 5. So that's 6 factors. I'm multiplying 5 by itself a total of 6 times. So as a single power, that's 5 to the exponent 6. So let's just keep track of what's going on here. When you multiply two powers with the same base, you add the exponents. When you divide powers with the same base, you subtract the exponents. When it's a power of a power, what do I do with the exponents to get the exponent on the single power? Can you see it already? 3 times 2 is 6, and that's what my exponent ends up being. So try the rest. Pause the video, see how you do. The base is 3. 2 times 4 is 8. So our single power is 3 to the exponent 8. The base is 2. The exponents are 2 and 3, so 2 times 3 is 6. Our single power is 2 to the exponent 6. The base is 6. 5 times 2 is 10, so here we have 6 to the exponent 10. And here, the base is 4. 3 times 3 is 9. So 4 to the exponent 9 is our single power. So the rule for simplifying a power of a power is you multiply the exponents together to get the exponent in the single power. So you have these rules for multiplying powers with the same base, dividing powers with the same base, and a power of a power. Use those rules to try the practice questions, and if you get stuck, let me know so that I can help.